So we got our first question here. Does the amount of LDLR mRNA increase or decrease in a cell with low cholesterol? And let's draw the steps. So to start out, the amount of LDLR mRNA will increase. So because a cell will want to take in LDLR in order to raise cholesterol levels. So this will be done basically by, if you have your cell here, you say like you have your nucleus here, you say you have your Golgi up here, and you have your SREB P2 enters into the Golgi, and bound to it is the scab. And while in this, it'll be cleaved by this twice. So little cleaver times 2. It'll be cleaved twice, and when it's cleaved twice, the SREB P2 will then be activated. And then the SREB P2, once activated, will go to the nucleus, where then it'll be binding to the promoter. You have your TATA, and then everything, poly, all that stuff. But more importantly, we have our binding site for the SREB2, EBP2, that is the SRE1, and so then the SREBP2 will bind here, and then basically LDLR mRNA will be transcribed so that it can then be translated into LDLR protein. Moving on. Our second question is if you have one cell with low cholesterol and then another cell set with low cholesterol that is transfected with MK-2206, would the sets have different amounts of LDLR protein? Let me explain. So we know that from a figure 1 of the cholesterol paper, a description there, that MK-2206 induces LDLR expression. So right off the bat, you can easily answer this by the cell set with MK-2206 is going to have a greater amount of LDLR protein, or you could just say that's going to produce it at a higher rate because the cell with just low cholesterol is again going to want to bring in LDLR into the cell. So both are going to be, trying to increase their amounts of LDLR, but MK-2206 counteracts AKT, and AKT actually stops LDLR. So with the AKT counteracted by the MK-2206, it'll allow a greater rate of LDLR protein production. Again, this is all known from the figure 1, A and B.